Here we are given three functions for which we have to answer the set of questions like degree of numerator, degree of denominator, how the degrees relate, as well as the evaluate the functions at values of x equal to 5, 10, 20 and 50. And finally we have to answer the question how does y approaches or y approaches when x approaches larger value. So let's answer this set of questions for each of the functions. Now consider the first function f of x equals x minus 5 over x squared minus 5. So the question that we have to answer is degree of numerator polynomial, which is x minus 5. So basically the degree of a polynomial is the highest exponent of the variable involved. So here this is the x is the variable and the highest exponent in this polynomial is 1. So therefore the degree of numerator is 1. And now looking at the denominator term or the denominator polynomial, we have x squared minus 5. The highest exponent of the variable x is 2. So therefore the degree of denominator is 2. And how does the degrees relate? We see that the degree of numerator is less than degree of denominator. So you can say that the degree of numerator is less than degree of denominator. And now we have to evaluate the function at the values of x equal to 5, 10, 20 and 50. So basically you just have to plug in. I'll do it for one of the functions. So this is f of, if consider f of x equal to x minus 5 over x squared minus 4. If you have to evaluate for a function at any values of x, we simply have to plug the value into the function. So instead of x, I'm going to plug in 5. So this becomes 5 minus 5. And this becomes 5 squared minus 4, and this is equal to 5 minus 5 is 0 divided by any number. In fact, we can just calculate this. This is 25 minus 4, which is 0 by 21. It's still 0. So therefore the value of the function is at x equal to 5 is 0. So in the same way, we can plug in the values of x equal to 10, 20 and 15. So here I have done it already, which I have listed in the table format. When you plug in x equal to 10 for the function f of x equal to x minus 5 over x squared minus 4, you get the value approximately 0.052. I have approximated this to 3 decimal places. And when you plug in x equal to 20, you are getting 0.038. And when you plug in x equal to 15 to this function, you get 0.018. So we have evaluated the function at all these values of x. And then finally, we have to answer one more question related to this function, which is we have to answer how does y approaches when x becomes larger and larger. So let's do some analysis over here. Now looking at this table values, here x is increasing from 5, 10, 20 and 15. Now if you look at the values of f of x, this is at 5 it is 0. So we can just move on to the next value, that is 10. After 5 it is 0.052, and this is less, and this is less than the previous value. So it's basically approaching 0. When x becomes larger and larger, f of x approaches 0. So you can say that for the first function, f of x, or in fact y, approaches 0 when x approaches 0. So you have answered all three parts of this question, that is for the function f of x. Now let's move on to the second function, which is f of x equals 3x squared minus 5 over x squared minus 4. So let's calculate the degree. Degree of numerator is 3x squared minus 5, it is 2. And degree of denominator is, the denominator polynomial is x squared minus 4. So once again the degree is 2. How do the degrees relate? It is equivalent. So we say the degree of numerator is equal to degree of denominator. And then we plug in the values like x equal to 5, 10, 20 and 50 into this second function. And when we do that, we get these values, that is 3.333, 3.073, and when x equal to 20, 3.018 and 3.003. And you can clearly see that it approaches 3, because at 5 it is 3.333 and it is decreasing less than 3, and it is decreasing 3.018. Compared to the previous value, it is still less. As you can see, it is 3.003, which means it's approaching 3. So for the second function f of x, that is y, approaches 3 when x becomes larger and larger. And we will also have to answer one more question for this function f of x. That is, we have to uh, answer the leading coefficients. The leading coefficient is 3 over here. For the second function, it is 3. And for the denominator, it is 1. So we have 3 and 1 are the leading coefficients. This is for numerator polynomial, and this is for denominator polynomial. Let's now answer a similar question for the last function, that is f of x equal 4x cube minus of 5x plus 7 over x squared minus 4. The degree of numerator is clearly it is 3. That is this term. We have to consider this 4x cube term, which is the highest exponent, and degree of denominator polynomial is on second it is 2. So here they relate as numerator degree is greater than denominator degree. And we have evaluated the values. We get values like this at x equal to 5, 10, 20, and 50. So we can see that the f of x approaches larger value when x approaches larger values. It is initially it is 22 and 41, 80, and 200. So we can find some relation when x equal to 5, it is 22, and when x equal to 10, it is 41. So it's approximately 4 times of x. 20 times 4 is 80, 50 times 4 is 400. So we can say for the third function, f of x approaches 4 times of x as x becomes larger and larger. That is, it still approaches larger value, that is infinity. However, the relation is f of x approaches 4x. So we have answered all questions, all subparts of the questions for the three functions.